Okay, what we're doing, we're starting back. You guys remember a couple weeks ago when I said we did the one section, then I realized, oh, shucks, the SAT's coming soon. We got to stop and switch gears. So we got to go back to that. So we're doing chapter 6 again. You're going to need to know all this stuff again. So what's sine of 30? 1/2. Square root of 2 over 2. Square root of 3 over 2. 1/2. Square root of 2 over 2. 3 over 2. 3 over 3. 1 root 3. When sine positive? Top 2? Right 2? First and third. What's sine of 0? Sine of 90? Sine of 180? All right, so all this stuff that we've done in the past, we're going to need. Okay? What we did with this before was we said what was the sine of 150, right? Or we said what was the cosine of 240. And how did we do that? We said what's the reference angle? Well, my reference angle would be 60. I'm in the third quadrant. Cosine of 60 is 1/2, right? And then we're in the third quadrant. Cosine is negative in the third quadrant. That's what we did before, right? This chapter, we're doing the opposite of that. This chapter, the entire chapter, is on inverse functions. What are inverse functions? What do inverse functions do? They they undo what the original function did, right? Remember we had the inverse toaster discussion, right? The input was the bread, the machine toasted it, the output was nice warm hot toast. What would the inverse toaster do? You'd put nice warm hot toast in, the output would be cold bread. In case you burn your toast, that would be pretty sweet. You could start over. You don't have to throw you don't eat burnt toast. Nobody eats burnt toast. Okay. First thing we got to figure out. How do you find an inverse function? Gentlemen, how do you find an inverse function? If I give you y equals 2x squared minus 4 and say, what is the inverse function to that? There's a two-step process. Does anybody remember the two-step process to find the inverse? You rewrite it, but you switch the x and the y. So you write 2y squared minus 4. So step 1 is you swap the x and the y. What's step 2? Solve for y. Resolve for y. So I would add the 4, divide by 2, so it'd be x plus 4 over 2, and equals y squared, and then I would take the square root. So this is the inverse function to that. Okay? It is an ugly function. They don't have to be pretty. And what does that mean? Like, what does this and this being inverses mean? Well, what it means is if you were to plot points, let's say you plug in a 3. 3 squared is 9. 9 times 2 is 18. I should have picked a smaller number. 18 plus 4 is 22. What does that mean about this over here? That means if my input is 22, what's my output going to be? 3. And yeah, 18 minus 4 is, or 22 minus 4 is 18. 18 divided by 2 is 9. Square root of 9, 3. Easy enough? Does anybody remember what happens graphically? The graph of that is going to look something like this. Does anybody remember what happens to the graph of this? It is going to be sideways. Why is it going to be sideways? Reflects across the diagonal. It's the y equals x line. So all inverses, what they do is they reflect across that line. So basically this point moves to right there. This point only moves to right here. This point moves down here. And that's what ends up giving you that shape. Okay? Now, it's not that you're going to need to do a lot of graphs, but I'm going to use the inverse graphs to show you why things work throughout this chapter. Okay? So understanding that all inverse functions end up having that reflection, that's going to help us understand why things work the way they work throughout this chapter. Okay? Two things I need you to be able to do right now. One, if I give you this, you find the inverse function. And yes, you should be able to check to see if it works. What we're going to use them for is if the sine of 240 we said was negative a half, right? What we're now going to do is we're going to do inverse sines. Okay? We're going to answer these types of questions. Now, for questions like this, what I want your answers for is everything between 0 and 360. Basically, I want every single answer that this is true somewhere between 0 and 360. Okay? And in fact, we can go farther than that. I can actually say, you know what? Let's make it a little bit more challenging. Tell me every single answer to that. All of them. Think about what I just asked. What does a sine graph look like? What's the sine graph look like? That was that wave. Right? And that wave keeps going, doesn't it? Forever and ever and ever. What do you think the inverse graph is going to look like then? What's going to happen is it's going to go this way. And yes. Okay? Now, what we just said, here's negative a half. What we have to find is where does this graph hit that point? Well, it's going to hit it right there, isn't it? Well, it's also going to hit it right there, and it's also going to hit it right there, and it's also going to hit it right there, and it's also going to hit it right there. How many times is that going to hit that point? An infinite number of times. The answer to this question has an infinite number of answers, and we're going to find them all. I know, isn't it mind-blowing? It's easy. We're going to do it the same way. When does sine equal a half? What's my reference angle? 30. What quadrants, plural, is sine negative? Bottom two. What's a 30 in the third? 210? What's 30 in the fourth? 330, right? Good. That's two of the infinite number of answers, right? Okay. What do you think? Oops, I went the wrong way. What do you think? Let me redraw this so it's a little bit bigger. What do you think the distance between this point here and this point here is? What do you think that distance is? We're in degrees. What's this distance from here to here? What's one cycle of it worth? Isn't that 360? What do you think the distance from here to here is? It's 360. What do you think the distance from here to here is? It's 360. So, if we just keep adding 360 to this, any number of times, we're going to keep getting more and more and more answers. So if you just add this plus 360n, assuming n is an integer like 1, 2, 3, 4, or even -1, -2, -3, that gets all of them. So you're just going to add that to all your answers. It really is that easy. Yeah. All right, everybody open up page 253. We're doing homework together. And take out a sheet of paper. We're going to rapid fire, get as much of your homework done in class together right now. What? 2 more days. I don't know. No. No. All right, your homework is page 253. We're doing the evens up to 32. That's your homework. All right, we're doing these together. Practice exercises. So number 2, the directions say graph the relation and its inverse. And they give you y equals 2x. What's the graph of y equals 2x look like? It's a straight line, isn't it? With a slope of 2. So it's going to look something like this. How do you find its inverse? You'd say x equals 2y. So then what would y equal? 1/2 x, which is the same thing as just y equals 1/2 x. So what would its inverse look like? Well, it's just a slope of 1/2. It's a line that's less steep. Ta-da. All right, number 4. Y equals 6x. Find its inverse. All right, you guys should already be able to tell me the answer. What's the answer? X over 6 or 1/6 x? How about number 6? Y equals x plus 13. I would go x equals y plus 13. So what's y going to equal? X minus 13. That's the inverse. Are these pretty easy? Okay. You don't need to do number 23. That's an odd number. I'll show you. I'll get you. I'll show you there when we get there. Okay. Everybody get through number 14 and then stop. Does anybody want me to do anything up to 14? You guys good? All the way through 14? Easy? All right. You don't have to draw the graphs to this section. You only have to draw the graphs to the first question. It's not my fault you can't read the directions. It just says find the inverse. That's all it says.
You know, you never said. You know, it's
Your mom. All right. I want you guys to look up here real quick. There are two different problems on the board. One says, how do you read this one? What is the inverse sine of 1? How do you read this one? You say, what's the inverse sine of 1? These are the exact same thing. The reason we have this is it's just a notation problem. Some mathematicians think other mathematicians write things incorrectly, and they write things misleading. Some people don't like this notation because it looks like sine raised to the negative first power, but it's not. This is not sine to the negative first power. They're not the same thing. The reason they use this notation is a lot of times in function notation, if you say f of x is equal to x plus 13, then the way you write its inverse is you put f and you put a little negative 1 there. This means the inverse. Some mathematicians don't like this with trig functions because it looks like an exponent. So because it looks like an exponent, they say you have to write it like this. Well, some mathematicians go, I'm not an idiot. I know this just means inverse, so I'm just going to go with it because it's easier to write. These two problems are the exact same problem. They mean the exact same thing. So don't get confused. If you see sine to the negative 1, if you see arc sine, they both mean inverse. Okay? So, number 16. Let's do that one together. It says, what is the inverse cosine of 0? When does cosine equal 0? There's two spots. They are 90 and 270, right? So all you write is 90 plus 360n and 270 plus 360n. And you done. What's the next one? Arc sine, negative 1. What's the inverse sine of negative 1? When does sine equal negative 1? Did you say 390? Ooh, I think sine. It's one of our quadrantals. 270. There's going to be two answers to every single one of these unless it's a 1 or negative 1. Because think about the curve. How many times does the curve get to the peak? Only once. And then it gets to the bottom peak only once. All right. How about number 20? Are 18 and 20 the exact same question? They really are. One says arc, one says sine to the negative 1, but those both mean inverse sine. It's negative 1. The answer is? No. 2. Oh, ignore the directions for the whole book. The whole chapter, ignore the directions for all the radian. I'm not making you do any more radians this year. Don't even worry about it. Just do everything in degrees. You're welcome. You guys too. Okay? Huh? Yeah, they're not going to watch this video, so they're all going to do them in radians, and I'm going to say, ha-ha, you should have watched the video. Yeah. All right, let's do 22. Inverse cosine, what is it, negative 1? When does cosine equal negative 1? 180. Plus 360n. Okay. What's the next one? 24. Arc sine. Negative square root of 3 over 2. When does sine equal square root of 3 over 2? What's my reference angle? 60. It's negative. What two quadrants? What two quadrants is sine negative? Bottom two. What's a 60 in the third? 240. What's a 60 in the fourth? 300. And all you have to add is plus 360 in. Isn't this stuff easy? What's 26? Arc cosine. Square root of 2 over 2. When does cosine equal square root of 2 over 2? 45. What two quadrants is cosine positive? Try again. Positive. First and fourth. What's 45 in the first? 45. What's 45 in the fourth? 315. And then you just add plus 360 in. Plus 360 in. Today, to-da. Yeah. I know. All you got to do is 28, 30, and 32, and all those are find the inverse and graph it this time. I honestly don't even care if you graph the last three. I don't even care. Just find the inverse. Good? That's it.